Hi there, welcome back. This is John Stewart's Calculus Early Transcendentals 9th edition. This is section 3.1, question 31, and the instructions for this problem just say to differentiate the function, so I'll jump right into it. As you can see, when you look at the problem on the bottom, there's the 4t cubed in brackets, and that's basically what's preventing us from using our basic polynomial derivative rule. So we've got to get rid of that ugly denominator, so let's try and get rid of that. Remember, the denominator's cubic function is on the outside of the bracket, so when we're doing our cubing, we have to cube everything inside the bracket. So that's the 4 and the t. A common mistake is basically we forget about the brackets, and we forget to cube the 4 as well. That's basically the difference between, say, 4t cubed and bracket 4t, closing bracket cubed. So to summarize, 4t cubed would be equal to 4t times 4t times 4t, which is just 64t cubed, which is considerably different than just 4t cubed. It's about 8 times larger. Or sorry, 16 times larger. Anyways, and so therefore, once we do all the expansion, we can replace that open bracket 4t closing bracket cubed with a 64t. So that's kind of our first step, and it's starting to look a little bit more normal. Now, for the second step, I just want you to think of a circle, right? Another way that you can write a circle is just the number 1, because it's the whole circle. It's one circle. And you can also imagine that we break that circle up into, say, 6 equal parts, and you could just pretend that those parts are all equal and that I have the AutoCAD skills to do that. And we can look at that as being 6 over 6. Now, the interesting part is you can break that 6 over 6 again into different things. So, for example, this 6 parts, we could break it into 1, 6, and 5, 6. And if you wanted to, you could make that over 6, right? And have 1 plus 5, and then you can separate it again into its individual components. So the point being is that if you have something on the bottom, you can divide each term by what's on the bottom as a way of breaking it up. And we have 2 examples here. One is that 6 over 6 is equivalent of 1 6 plus 5 6, and hopefully you guys can all sort of see that looking at the circle. That if you took just one slice and you added it to the rest of the slices, you get the whole circle. And you can pick any slice you want. You could take it out, put it back, and once you put it back, you have the full circle again. Same thing, you could take two slices out at the time, and together 2 slices that are out and the 4 slices that remain make up the whole circle. Right? Great, and so basically we're going to apply that trick from the circle here to take that 64 over t cubed and the 2 parts on the top and basically just split it. So, that was pretty quick. If you look on the right-hand term, you'll notice there's a t squared on the top and a t cubed on the bottom. That means if we cross off the t squared, we can get rid of 2 of those t's on the bottom as well. And then the next step is we have a 16 on the top and a 64 on the bottom, which is the same as 1/4. So we can replace that 16 over 64 with 1/4. And now our system is looking a little bit simpler. The only thing which we really have to do to use our standard formula is we have to move that t cubed and the t up to the top. So for that, we have to move on to the next slide. Okay, so with this slide here, basically the trick of algebra and the way that we move that t cubed up the top is if you change the 3 in that t cubed, you can make it negative. Or sorry, you can change it from positive to negative, and it moves it from the bottom to the top, or from the denominator to the numerator, depending on if you want to use more mathematical terms. And of course, remember that t is really t to the power of 1. We just love being lazy, and we never really write that 1. So after we move to the top, that t cubed becomes 64t to negative cubed, and that 4t just becomes 4t to negative 1. And now we got into basic format where we can use our polynomial rule. And remember, when you're basically taking derivative of a polynomial, all that you're really doing is bringing the number and the exponent down in front and subtracting 1 from it. And you can think of this as 2 separate derivatives if you want. And to make it even easier, you could take out the constants in front to take out that 64 and 4. So now all that you're doing is you're just doing the derivative of t to negative 3. So we take that, so for the first term, we take that negative 3 out in front, and then we subtract 1 from negative 3. And for the second term, we take the the negative 1 out in front, and we subtract 1 from the negative 1. And so on the next line, you can see you have 64 times the negative 3, and the 3 minus 1, which just gave you negative 4 in the first term. In the second term, you have the negative 1 still in front, and minus 1 minus 1 is just negative 2. And so there you go. Now 64 times negative 3 is it's negative 192. And of course, plus 4 times negative 1 is negative 4. And yeah, that's pretty much it. Now, the only thing which you might want to do, depending on how strict your professor is they might want you to get rid of the negative t's by moving it back downstairs. And you do that, you basically can just make the negative t into a positive t as you move it downstairs, because anytime you flip it from top to bottom, you're always negating the power. And so we can also look at this exact same thing as negative 192 over t to the 4 minus 4 over t squared. It just depends what your prof likes. I mean, for me, I think the one up top is perfectly fine, but if your prof is really a stickler, he might want it to look the way it does down below. Alright, so sorry for a bit of a long explanation, but there's a bunch of algebra tricks you have to know in order to solve this problem, and hopefully I made that clear. If you have a specific problem you'd like a breakdown or walkthrough for, just let me know in the comments below or email me a picture of the problem and I'll see if I can do it for you guys. Thank you. Have a good day.